Buongiorno Milano, glad to be here. Today we're going to talk about deploying Go function, and I would like to have your undivided attention for a moment because it's going to get complicated really fast. So as you can see, we're going to deploy Go function. So you come here, you click deploy, you type Go, you select, and you deploy. There. Thank you for coming. Do you have any question? No, but we laugh about it, but we often underestimate how something that's simple is actually really complicated behind the scene. And this is what this talk is about. It's about simplicity and what we can do about it. How can we recognize it? So, as you can see, I just deployed a simple function. And what this function do is just detecting faces. I know nothing about detecting faces as the algorithm behind detecting faces. But here, I just look for an image of astronaut because they have like clear faces. I just copy, invoke the function. Hopefully, it will get warmed up. It will process that image and give me the detection of faces. To be able to do that in just a few clicks without any knowledge, I think it's a tribute to all those people who worked on that. Like, I'm not the smartest guy just because I pushed the button. They all contribute to a long line of little pieces together that allows me, someone who doesn't know anything about it, to just use that and consume that service. But it doesn't stop there, because when we think about just function, there is the whole set of things that we can do around it. Like, for instance, I have this very simple cow say. It's just, whenever I invoke it, it returns a text. And now I want to see, like, what's the metric about it? And so I have this tool called linkd that is coupled with OpenFaz. Both of those tools are open source. They are both running on a Kubernetes cluster. Do you know how much code did I have to write to get them up and running? 0. No code is the best code. And so if I want to see a little bit, like test my function, because it's nice, how do I know that my function is working? I want to have some visibility about it. So I'm coming to here, there's this little tool called Hey. It's going to hammer this API for 30 seconds with a 16 concurrent connection. And hopefully, that will give me some insights to whatever this function is working or not. I'm just generating some traffic. And with linkd, out of the box, I have this beautiful dashboard. I don't know if you ever had to build a dashboard yourself, but to reach that level of consistency across all your application, this is like beauty. I mean, to be able to find out that no matter what service I'm going to check, I have the same dashboard, this kind of familiarity makes teams very performant. And I can get a lot of information about it. I see directly that my function has been triggered. I had some information about the latency of that function, so I know how fast it works, not only if it works. And all of that without writing any single line of code. There is value into reusing what others has done. And so, as you can see, this might not be like super advanced feature, but it pays a lot in the long term. And not only in the long term, it's like the architecture of those people, I'm going to describe it to you. The people who built that architecture are actually, with those 3 lines of code, you can reproduce most of what I did here. Everything I say, all the links, they are in the slides, so don't worry about missing out. But you don't have to know much about it to try experimenting with it. And so, but when we talk about serverless, it's like, what's the code? Like, how should I program to write my code? Well, let's start a little bit to step back and see what is the code that, if I had to build my own, what should I build it with? So you have here a very simple Go program. Like, you have some import, you have a handler function, you read from standard input, So, you know, the basic input of any programming language. If there is a problem, you print an error. If not, you just print out the result of calling that input with that function. So this is the simple template that I don't even need to write. This is all what's behind the scene. If you want to see the code, this is the code. This is a simple function that just take the input, do some string manipulation, and reply. And that's it. The beauty of it is the API. So what it means here is just basically a string of bytes, an array of bytes, and returns a string. That's as simple as that. You program towards an API and not some more advanced construct. And for that, I want to show you the code of the function I used for face detection, which is actually, if the network allows, it's 227 lines of code. This is something that in a few minutes I can read and understand. You don't even need to know Go to know what's going on. You know, you have a lot of import, some structure, the function, and most of it is just massaging the input and some configuration. It's not so much code, it's more like configuration. And then you can see that you have some structure, detect face, and we're getting somewhere. So you can see that there, I read the whole code. Most of it is processing the input and packaging the output. Most of the function is actually in one function that can be seen. Detect faces. There is some parameter that you can tune to your knowledge. I mean, you don't need to know much about face detection to start experimenting with it. And that's the difference. You don't need to know everything everything there is to know about it in order to be productive. So now I have my function, I have the wrapper of that function, and I package it into a container. I put some process environmental variable, this is the compiled function. And I have this process, it's called a watchdog. All it does is just listening to HTTP request and package it into, injecting it to the right handler process. And that's it. Like if you want to build yourself your own function as a service, you can start with a few lines of code. So it's not so much as complicated as the simplicity in it is beautiful. And so that's all it does. You have a gateway in front that listens to a path. That path is actually the function name. It runs inside a container, so you have the gateway that routes the call to the right function. This function has a watchdog inside that converts this HTTP request to whatever format is there inside the container and process in standard input and a standard output. Does it ring a bell, this standard input and standard output? You know the Unix philosophy, where they process stream of text? Well, this is why deploying Go function is actually quite interesting. Simplicity is complicated. And by talking about Unix programming, I was just on holiday, and one of the books that I really wanted to read for a long time was this, because one day I heard a consultant talking about someone who is actually a Unix specialist. And he said something that stayed with me for a very long time, and that is, every business problem can be broken down into single Unix process. And I didn't understand at the time. It took me a while to process that, and that's why I made this talk. I want to save you a lot of pain for going to your serverless journey. I read that book, and actually Rob Pike, who is the inventor, I would say, of Go, he didn't work on Unix per se, but he didn't invent Unix, but he worked on it. And you can see that he brought a lot of concept to the Go language, which is simplicity. In Go, which is just a simple keyword that is Go, so it's 2 characters, you can spawn off a thread. I don't know for you, but in any other language, it's quite hard to manage thread and process. So I put the link of the talk down below. Feel free to watch it. I think it's totally worth your time. But in this talk, he explained that, and don't take it from me, take him for the inventor of Go, that make something simple is actually really complicated. And the one thing that we often underestimate is that infrastructure is actually really complicated. We don't see it because now with the cloud and everything, it's just one API call and we get a cluster. Who knows what's behind? And so there is another person that I recommend you watch a talk, is Evgeny Berkman, who wrote about 300,000 lines of Terraform code. And he just shared a lot of his wisdom about infrastructure. And people don't often realize that many companies are migrating to the cloud now. They already have on-prem, and they have to change all the architecture because the cloud per VM is more expensive. So you cannot just lift and shift. This is going to really cost a lot. So they have to re-architect things. And they say, like, before you start your journey, know that if you want an entire cloud infrastructure, it's going to take 6 to 24 months. I think that's in the best case scenario. I would say about 5 years. If you start, you know that 5 years later, you can say, yeah, we are fully on the cloud. This is the amount of time. This is the time frame that you look when you start talking about a migration, if you have legacy. And it's all about projecting about how long a project will take. It's always more than what you expect. But why does it take so long? Just imagine you come home, you turn off the lamp is broken. So you go to the shelf, but the shelf is a little bit broken, so you look at it, and you want to fix it, but the drawer in which the screwdriver is making a little bit of noise. And so you look and look for the oil, and the oil is empty. So you have to go to the store, but your car broke down. So now, finally, your manager comes in and says, why is the lamp broken? And you say, I'm fixing it. You understand? This is called yak shaving. It's all the little thing you have to do before doing the thing you were supposed to do. That little color button on the website, you end up fighting certificates on the other, and everything broke down. And people ask, like, why does it take so long? And you cannot even express with words all the little thing because those are details that people don't care about. And that's why simplicity is complicated. I heard that phrase, I said that phrase. I regret it so dearly. Like, that's my redemption. This talk is my redemption because I said that, and 3 weeks down the road, I was crying. We should build our own X. And X, I mean anything that is not related to your business. I'll give you some example. Framework. Who said that? We should build our own framework. Congratulations. Did you like it? No. Welcome to the club. So, I heard those things. These are real examples. I heard we should build our own in-memory database. Well, how long do you think it's going to take to find all the edge cases and hardening and securing those in-memory databases? Or queuing system, or let's build our new programming language. Do you know, like, per employee, per line of code, building a language is the most expensive things in the world. Like, this is madness. This is millions of man-hours dedicated to convert a higher-level language to machine code and make that optimizable. You don't believe me? Just try to build your own. See if it's performant. And so the idea, the only thing that I learned from that is really that we could build it. We have the technical skills to build it. But spending time on the business makes more sense financially. And here is why. Now we are in a new era where there is all those buzzwords like site reliability engineering, cloud migration, and all those things. And suddenly, because you consume service that you pay for what you use, you have to be cost conscious. So before, it was just a matter of resources. A developer just had to manage memory and CPU and maybe networking, which, to be honest, most of them didn't care at all about it. When you see, you spin up a JVM and suddenly you have how many gig of RAM that's already taken. But because it's not the JVM that's the problem, it's just that time to market is more important than the memory. Renting a machine is always cheaper than hiring someone. And that's why we don't care about resources anymore, unless we pay for them. So now the circle is complete. Before, when I saw this morning in the keynote, they were sending people to the moon with just a few kilobytes. Now we are going back to this cost-conscious approach and resource-conscious approach because we receive the bill of whatever we use. And if you don't believe me, take it from someone who built the Google Cloud infrastructure. So I'm going to read this tweet so you can understand. So Lyft is paying $8 million a month in AWS rent. That's almost 100 million a year. Each ride costs 14 cents in AWS rent. I keep hearing they could build their own data center and save. My early days at Google, I heard the same from customers. At scale, owning is cheaper. It wasn't. They all came around. And I highly recommend you read that thread because it's eye-opening for me. It was about total cost of ownership. You know, the cost of running a data center is huge. You have to connect to the network. There is not so many telecom company that can afford or can provide you with a service. So there is not so much competition. So they charge premium just to give you access to the internet. Then you have all this compliance, security, redundancy because disk blew up all the time. And suddenly you have to manage a data center when it's probably not your business to run data center. And so that's why the keeping focus on what the business is and allocating resource to solving business problem is a nice trade-off that you need to be aware of. I give you another example. Restaurants buy food, cook, and sell food. Very few of them do farming, and even fewer do it right, or good, I would say. And it's true. If you go to a restaurant, they might farm their own food, but what about stock management? Like you might come up one day and the menu completely changed because the availability of the food was not there. And it depends what you want to do. Do you want to focus on cooking the best food, or do you want to focus on farming the best food? So let's take a step back. Let's see, why deploying Go function? Because we have mental limitation. The first mental limitation we have is the number of decisions you can make per day. I guarantee that you look at the high-performing people, they always have habit. Like they say, the 10 most common habits of high-performing people. They miss the point. The important thing is not the 10. The important thing is that they had habits, because habits make everything automated. They didn't have to think about it. It's like, okay, that's it. This is how my day is going to look like, so my mental resources are free up in order to focus my brain onto what's matter. Also, the number of things to remember. This is called mnemonics. Usually, a person can remember at any given time 5 to 12 things. The problem is that if you stress, if you lack food or water or sleep, or you have pain somewhere or you're stressed, you can remove for each of these blockage, you can remove one thing. So it's possible that at some point you reach 0. You are not able to remember anything at any given time because your body doesn't allow it. And of course, you also have the speed of memory reflexes. You remember that library you wrote 6 months ago? Are you really sure? Do you really remember how it works? And can you explain it to someone? I mean, the code is liability. And if you remember anything from this talk, is this. So when doing some research about chaos engineering and how organizations work, I found this paper that's by the US Air Force. So they made a study about pilot error specifically. What they found out is actually really interesting, is half of the error a pilot made is what they call substitution error. What is a substitution error? Is that when a pilot goes into the plane, he or she expects to have the latitude or the altitude and the speed and all those metrics on the dashboard at the same place. Because when you're in combat, it's not like you're going to make some kind of long-term decision. Should I look at this? Can you fine-tune? No, it's muscle memory. And so half of the mistake were all removed just by standardizing the dashboard. Not the plane, the dashboard. So the way the pilot interacts with the plane is now standardized. One pilot can pilot more planes. Do you see the correlation with how we build our tooling? Can you really say that, okay, if I take one developer and I put him in another team, is he going to be efficient, productive? Consistency is key. So again, let's take a step back and come back to the talk. Why are we deploying Go function? Do you know Kelsey Hightower? He created a nice repository. I love it. It's called No Code. No code is the best way to write secure and reliable application. Write nothing, deploy nowhere. Getting started. Start by not writing any code. So far, so good. I highly recommend that you read that repository if you want a good laugh, because there is about 2,500 issues, and most of them, I don't know what kind of issue they have with no code, but no coding, no bug. I mean, and the pull request, this is brilliant. I'm sure somebody had a pull request for update Docker file. Yeah, of course. So, you know, those kind of things, they are laughable, but this is what really makes us laugh is that it's true. No code is the most reliable application ever. So this is the mindset of a serverless application. Serverless is, I think they got the wrong order in the words. It's not, I want serverless, it's I want less server. Meaning I want to manage less server. I don't want to care so much about server. I want to focus on the business. And again, don't take it from me, just take it by the person who coined the DevOps term. So he explained that his talk is from serverless to service full, because you have to think in terms of service. You cannot do anything if the bucket from the cloud provider you're using is down, meaning that you don't have access to the code, you cannot talk to a human about it, you can just prepare in case this goes down, you have a backup plan. And that's a completely different approach than say you're responsible for it. You understand the difference. It's more about preparing in case something goes wrong instead of hoping and blaming someone for it. And you can try this, like name a service for the mails that you're using, a chat, storage of pictures or files. Are you going to build your own? Or storing code, or even DNS. How many people have rewrite the service discovery idea? How do services find each other? Well, DNS. That's how it works. Or even a payment processing gateway. Do you really feel confident is as a side project to what you're building, you're going to bring a payment processing gateway that's going to process the money you bring in? Are you that confident about it? So would you write your own? Probably not. So you're already using services that are serverless in the sense that you don't care where they run. You just want them to run. I mean, if I go to my bank, I don't really care what framework they use. I just want to make sure that the money is at least as good as what it was last time. And so it's all about trade-off. You can trade developer time compared to user product. For some reason, I don't know why, but in the head of manager, developer time is always 0. Like it doesn't cost anything, which is not true. It's just that they feel they're already paying for it and they don't want to pay more. So that's a human bias that we have to take into consideration. And also the trade-off is that if you're on-premise or if you're in the cloud, on-premise you have fixed capacity. In the cloud you pay for what you use. So the strategy you're going to have is different. And again, if you have a service that is latency critical versus throughput critical, meaning do you need the answer fast or do you need to handle a lot of answers? This depends on your strategy. Strategy is a word that means how you're going to play the game. And for that, again, don't take it from me, take it from someone who wrote the book on strategy with something called mapping. It says that map, because they are visual, they have some properties that allow us to communicate more clearly than by text. And so you take an example of an online printing service. So you send a picture and you receive the printed picture back. And it says here all the dependency chain of everything. On top you have the customer, then you have the online photo storage, and down at the bottom you have power. You're not going to reinvent electricity to run that business, right? You're not even going to, you might have to host that yourself on your server, but you could very much use, you have the opportunity to use somebody else's compute, like the cloud. And so you see, whatever is on the left, on your left from the map, is something that it doesn't exist. It's not available. You have to create yourself. Everything that's on the right is something that you can get with a credit card. And so the idea is really that with that, you can communicate clearly and you can know what you should build and what you should buy. And so why do we deploy Go function? Because pipeline are software too. Pipelines, build pipelines or test pipelines, are the way you apply change to your system. And so usually the code of the pipeline is usually much bigger than the function code, meaning that you can focus on the pipeline and the code is very much faster to get feedback on. And so this tendency now it's called the shift left approach, meaning that the earlier in this process you get feedback, the faster you can apply change, which makes sense. If you ship something to production and you only find a problem while monitoring the service, or the support team comes back saying we have a problem, it's going to take a while before you apply the change. But if you see that one test failed, it's minutes before it gets fixed, probably. So that as well is something to take into consideration. Where do you want to spend your time? And of course, what helps is having everything as code. So you have, for infrastructure, you can have Terraform. That's just one tool. You have many. For configuration, usually YAML is the preferred way these days. To build your application, you can have a Docker file. Those are code. You can inspect them. You can share them. You can reason about it. It's not just ideas that are abstract or stored in somebody's mind. This is actual thing that, this is data. Data that you can query. Policy, you can enforce that with code now. Who has access to what? Deployment. A Kubernetes YAML deployment is just the common way one way to deploy an application. And you can be sure that you will have no downtime because of the rolling nature of the deployment in Kubernetes. Even for your pipeline. You have use Jenkins, or you can use the latest Tekton, which is based on Pro. Pro is what is the project that was created to actually build Kubernetes. And it was the architecture was quite nice because it uses containers, steps of containers to build something. And this idea got spread all over. So now I'm pretty sure in a few years, this is the way you're going to build your pipelines. And resiliency. Chaos engineering is also one term that gets a really bad reputation because they think the word chaos scares people because they don't know what it is. But chaos engineering, many times, has been it's not about injecting chaos, it's about revealing the chaos that's already in the cluster. Meaning that you want to know what happened when something goes wrong. You reveal the chaos, you don't add chaos. You just trigger it in a controlled way so that you can know. It's about finding information. And I mentioned this chaos toolkit because it provides you a way to write your chaos experiment and share it. Just imagine, if you write an experiment for your cluster and say, okay, this is what's going to happen, here is what I expect, here is how to remediate in case something goes wrong. You can share that to someone and say, I have those guarantees. I know I can guarantee that many requests under those circumstances. And you can test that. This is something that this is valuable information. And so again, let's take a step back and see why we want to deploy Go function. Because you can either focus on code, or You can focus on code, business features, security, monitoring, performance, productivity, SLI, SLO, SLA, and cost and resource management. Like, which one is bring the most value to your business? And so again, why do we deploy Go function? I like that in the keynote today they show Cloud Run, so this is the perfect demo. This is actually the code that you need to use Cloud Run with the face detection that I showed earlier. The idea is that I have a container, and I don't care. I don't want to write a Kubernetes manifest. I just want it to run. I just wanted to use it. I don't have that much traffic that I care about, super reliability. I just want to get something up and running. And so, let's see. All it does here is, this is just to tag the container image and upload it to Google Cloud, because that's where the Cloud Run runs. Then I deploy the container. From there, I receive the function URL that I can query. I take an image. As you can see, it's probably one of the NASA picture you can see, and I can curl with the image and get a target. So let's see if we can have that working. It seems a bit slow because it needs to get, but OK. Open target. And it seems to work. Now, let's check that it's not something that was stored on my laptop. So if I check what is the picture, that was the previous one. Yeah, it seems like it's the same picture, so it worked. As you can see, simplicity is complicated. I didn't have to write all that YAML. This is all I need. I needed one command, some configuration, here you go, run it. And that, in terms of business development, on time to market, this has a real impact. Like, this is money to manager. They understand that. You talk about container, Cloud Run, and everything, like nobody understands. You talk money about how much time you're going to spend developing something. They're going to listen to you so carefully. And so, where are we? Here you go. That's all for me. If you have any resource, or if you want more resource on that, you can just link in the slides. All of that, and that's what I do at the end of my talk, is I'm so sorry if you had to maintain my code. I hope you learn more by maintaining it than me by writing it. That's my redemption. I hope that all the people who maintain the bad code I wrote back in the days will forgive me. Thank you for your attention.